It's fairly interesting and it's fairly important. Okay? It's easy to get lost. Okay? The problem that most people have with this is that they try to go too quick about it. Okay? So most of the time you're going to make lots of careless mistakes. Okay, so just kind of take it nice and slow, be deliberate, you should be okay, all right? All right, 7.2, anti-differentiation. Anti-differentiation, now we're gonna do indefinite integrals. So far we have, all of our integrals have been definite integrals where we had a definite A to B. Okay, we had a specific where we start and where we finish, okay? Your indefinite integrals are going to look like this. They're indefinite. They are not definite. Okay, so you're looking at the anti-differentiations, and so you're going to get nothing more than this, and that's all you're going to get. Okay, because there's no boundary here from 1 to 2. You can't do the evaluation from 1 to 2. You're just going to get a function. Okay, that makes sense, I hope. So let's go to the green box on page 340. Family of all antiderivatives of a function is the indefinite integral of f with respect to x. And that's why you have C there, right? We're going to talk about the family or group of functions that are going to work, right? So let's go ahead and see if we can do this in example number 1. Example number 1, we have x squared minus sine x. I have x squared minus sine x d of x. So we're going to go nothing more than x cubed over 3. And what is the derivative? What was the anti-differentiation of this? Is it plus cosine or minus cosine? What is the difference? What happens when I differentiate cosine x? I get negative sine x, right? So this would be a positive, correct? So I need to end up with a negative over here, right? So that's going to be your answer. Simple as that, right? Let's go to page 341. Look at the properties. There's a huge green box there. Most of it should be review, read through, and see if there's anything that does not make sense to you. Oh, hey, Caden's here. I guess he's done snow blowing. Okay, so the first one, properties. Okay, the first one is nothing more than being able to pull a constant out in front. The next line is the same as just the sum and differences from the other one. Okay, now let's start looking at the power formulas. Okay, u to the n is n plus 1 over u to the n plus 1 divided by n plus 1. Then you accept from when it's minus 1, then it's just a natural log. You have the trig stuff. I hope at least the left-hand side rings a bell. Also, the top one on the right-hand side should be okay. The other two, kind of iffy there, huh? You remember that one, right? Okay, the exponential logarithms. Okay, exponential e to the x, natural log of u, log base a of u. Okay, all kind of good stuff. Example number 2. So we can do example number 2. Example number 2, we have verify that the antiderivatives are that. Okay, well, the way you're going to do that is that we're trying to verify that it's equal to this guy. Okay, so I would just take the derivative of this side, right? And see if you end up with this. That's what you should do, right? If I take the derivative of this, I should end up with this guy. So if I take the derivative of this, what do I get? 1 over u, which is u to the negative 1. Right? Pretty simple, right? Because this goes away. So we're good with that. 2 or b, whatever it may be, b natural log of u du is equal to u natural log of u minus u plus c. Okay, now it's a little more complicated. Again, I'm going to take the derivative of this side to see if I come up with this guy. Right? So if I take the derivative of this guy, I get u. Well, we'll write this out. Taking the derivative of this, so this would be what? What am I going to use here to differentiate this? It's going to be the product rule, right? Remember way back when we did this? Right? U prime v plus uv prime, right? That's what we're going to do. So I'm going to take the derivative of this guy. If I take the derivative of u, I get 1, and then I'm just going to get this guy plus u. Then I'm going to take the derivative of natural log of u, which is 1 over u. And here, I take the derivative of that, I get -1. C goes away. U over u is 1. 1 minus 1 is 0. Ta-da! Natural log of u. Right? It works. So all we did was verify. Okay? We were not asked to derive it. All we're doing is verifying, right? Let's move on to page 342, Leibniz notation and antiderivatives. Nothing much going on here. Let's see if we can do example number 3. Example number 3 looks very innocuous, and they all kind of look the same, but there are quite a bit different here. So let's do example number 3. I have f of x is equal to x cubed plus 1. And then I have, what else do I have? U is equal to x squared. Find each of the following antiderivatives in terms of x. So they first want me to do f of x dx. So this is simple. I'm just going to go ahead and put this guy right in here. X cubed plus 1 dx. So it's going to be x to the 4th over 4 plus x plus c. Okay. Okay, so this, oh, forgot. So antiderivative is the part where we actually get this c, right? Okay. I can tell you right now, you guys, some of you guys are going to lose points on the test by forgetting this c. It just breaks my heart when I have to give you points off, take points off because you do everything right and then forget the plus. I will tell you right now, it's really hard, but I will take points away. Okay?
It's really hard.
So, do not forget this, is what I'm saying.
I think like a pass on the last test and maybe like the next test 2 points off.
So the thing is that I had one of the better, let's say this, one of the better math students, we took a test in this portion, right? And there was like, I think it was like 8 questions. And he had every one of them right. But he forgot the plus C on 5 of them. It was not a happy sight. Just letting you know. So let's not have that happen again. Okay? Right?
Did he show the work?
Yes, he did.
I'm just gonna put C on every single one.
Number 2, we have f of u du. Okay, so what are we going to do here? I'm going to do this. How do I do this? So this is basically the function f, and I'm putting u in there, am I not? Right? So what am I going to get? Isn't it the same thing? Right? F of
Plug it
u
into
cubed
your
plus
answer.
1 du, right? Which is going to be what? U to the fourth, 4 plus u plus c, right? And what does the question say? We're going to evaluate this in terms of x. Darn it. So I have to put this guy in here, right? So this is going to be x to the 8th. And this guy is going to be x squared. Correct? So if you leave it with the u's, you do not get full credit, right? Because it asks specifically in terms of x. Okay, so that's 2, 3. Oh, this is f of u dx. Dx. Okay, so f of u is this guy here, right? It's going to be u cubed plus 1 dx. But I know that u is equal to x squared, so I'm going to put that guy in here. So it's going to be x to the 6th, x to the 7th over 7 plus x plus c. Every single one of these things are different. They look almost the same, all different. They all have a C, as they should. Okay, all right? So you have to pay close attention. Again, be deliberate. Okay? Okay, now let's go ahead and actually jump into the substitution. So we're going to do actually now use the substitution method. Well, what is it? We don't know yet, right? But hey, it seems as though we will be substituting something, right? Substitution method, you would think so.
Is there elimination?
You wish. So you eliminate parts, so you don't have to do that part.
Yeah.
So I have sine of x e to the cosine x dx. What the heck is this? Okay, so I'm going to show you how to do the substitution method. We'll talk about the not the mechanics, but the thought behind it as we go. I'm going to show you how you do this. So you're going to go ahead and make the substitution, and we're going to call this u. And you are going to write this down, okay, so that you don't forget and you know what you're doing. Again, being deliberate. I'm going to take the derivative of both sides. This will be nothing more than du. Take the derivative of this side, I'm going to get what? Negative sine x dx. So actually what we were able to create here is we were able to create a situation where I have this guy now over here. You see that? Right? So if I rewrite this, I can rewrite this as e to the u, right? This guy here is that times negative du, right? So I'm going to pull the negative over, negative e to the u du. Oh, this is something I can do. This is negative e to the u plus c, correct? Except for u is, ta-da, that's my answer. So let's verify this. I'm going to go ahead and take the derivative of this, okay? We'll see what happens. If I take the derivative of this, I should get what? I should get this guy right here, right?
Looks right.
So let's go ahead and take the derivative of this. I'm going to get what? Negative e to the cosine x, but then I have to do the chain rule. So that would be negative sine x. The c goes away. Cancels out. Dun, 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 dun. It's there. right? So you see how the power of the substitution, okay? So what you have to do is you are trying to fit this as a puzzle to get this guy. You're trying to get this guy, right? By doing some sort of substitution.
Did you replace cosine x with u because it's the exponent? Like, how do you know what to put u in for?
Well, that's what I'm saying. So the reason why I put this as u is not necessarily because it's here, but because of this, the sine x dx, right? So in other words, to get that, I have to find what, when I differentiate it, gets me sine x dx. And that would have been cosine x, right? Because when I take the derivative of this, this is where I get this, which allows me to get rid of this, right? Again, there's a lot of stuff going on here, right? That's number 4. So let's do example number 5. Example number 5 is a little easier, actually. So example number 5, I have what? Example number 5, I have x squared, and then I have
square root 5 plus 2x.
5 plus 2x cubed dx. Okay, again, let's think about this. I'm going to try to get this guy. Okay? That would mean it would, when I take the derivative, I get squares. So the original substitution is going to be something cubed, x cubed, right?
Mm-hmm.
But look at this. I have this guy right here. So if I go ahead and take that whole thing and substitute it as u, okay, well now I take the derivative of this, what am I going to get? 6x squared dx is equal to du. I didn't quite get this, but all I'm going to do is divide this by 6. And I got that, right? I got what I was trying to accomplish right here. So now I can say this is going to be equal to square root of u. And this guy is going to be this, du over 6, right? So now I'm going to pull the 6 over, 1/6. Well, this is something I can do pretty simple, right? Because this is going to be what? 1 over 6, 3 over 2, u to the 3 over 2, right? What am I missing?
Something. Oh, the
C, the C, come on, man.
C.
You can't forget the C.
Almost forgot the C
You
there.
can't forget the C. Okay, so now if I take the derivative of this guy and this guy cancels out and I get u to the 1/2, which is basically this guy here, right? Okay, so now I just go ahead and do the multiplication. I get 3, 1 over 9. This is going to be the square, nope. This is going to be 5 plus 2x cubed, 3 over 2, plus, right? If you leave it like this, you will not get full points.
What if we establish what you?
Yeah, you can put this, but still, if you stop here, that's not what I'm interested, right? I'm interested in x's, not u's,
All
right? Okay. So that was kind of gnarly. Right?
right.
I'm gonna go ahead and we'll stop right here, okay? We'll stop right here.
Gnarly, bro.